Welcome to microScope, where we zoom in together to make sense of the world. Today, we're zooming in on something that feels magical, mysterious, and sometimes a little scary. Artificial intelligence. It writes, it talks, it makes art, it predicts the future. It recommends what you watch, buy, read, and even who you meet. AI is everywhere, powering apps, hospitals, cars, factories, and half the internet. And yet, almost nobody actually understands how it works. What is AI, really? How do systems like GPT models learn to read and write like humans? Why are digital twins the next leap? And what's the algorithm everyone keeps blaming for everything? Today, we're putting AI under the microscope. And once you see how it really works, you'll never look at technology the same way again. Let's begin. 1. What AI actually is. Not magic, just math. AI is not a brain. It's not alive. It doesn't think in the human sense. At its core, AI is a pattern machine. It learns from massive amounts of data and then uses those patterns to make predictions. Show it 1 million pictures of dogs. It learns what dogness looks like. Show it 1 billion sentences. It learns how language flows. Show it your Netflix history. It predicts your next binge watch. AI isn't guessing randomly. It's calculating probabilities. Extremely fast, extremely well. Think of it as supercharged autocomplete. But instead of finishing a text message, it can finish an essay, a code base, a research paper, or a business plan. If you're enjoying this breakdown of how AI actually works, consider liking the video. It helps microscope reach more curious minds who love clarity as much as you do. Let's keep going. 2. How GPTs work. The AI that reads, writes, and thinks in patterns. GPT stands for Generative Pre-trained Transformer. Let's break that down simply. Generative. It creates new content, text, ideas, answers. Pre-trained. Before you ever use it, it has already read huge amounts of text from books, websites, articles. A training phase that takes weeks on giant supercomputers. Transformer. This is the special architecture that lets AI understand context, not just words. Transformers don't read text like we do, line by line. They look at all relevant words at once and learn relationships between them. It's like giving the AI, here are 10 million puzzle pieces. Figure out how they all connect at once. GPTs don't know facts. They know patterns of how facts are talked about. Fun example. If you ask a GPT, what's the first thing I should do on Mars? It hasn't been to Mars. It doesn't know Mars. But it has seen text about Mars landings, astronauts, science fiction, oxygen, dust storms, habitats. So it predicts the most likely and meaningful answer based on patterns. It's not thinking, it's calculating meaning. 3. Why GPT models feel human. The illusion of intelligence. A strange thing happens with transformers. When they're trained on billions of sentences, they become extremely good at predicting what a human would likely say next. This gives us natural conversation, reasoning-like behavior, creativity, emotional tone mimicking, explanations, step-by-step logic. But it's still pattern prediction, just incredibly sophisticated. Think of GPT like a mirror. It reflects the patterns of human knowledge back to us. It's not human, but it has absorbed enough of human language to sound like one. If you're enjoying this breakdown of how AI actually works, consider liking the video. It helps microscope reach more curious minds who love clarity as much as you do. Let's keep going. 4. Digital twins. If GPTs are AI thinking in text, digital twins are AI thinking in models of reality. A digital twin is a virtual replica of something real, a factory, a city, your car, a power grid, a human body, even you someday. These digital copies update in real time, using sensors and data to mirror the real object. Imagine your house having a digital twin. It knows energy usage, temperature, weather impact, and can simulate improvements. Or a digital twin of your heart predicting health outcomes. Or a digital twin of a city simulating traffic before it happens. Digital twins allow AI not just to answer questions, but to test futures. They turn reality into a playground for prediction. 5. Algorithms. You hear this word constantly, the algorithm. But what is it? An algorithm is simply a set of rules that decide what happens next. In AI systems, algorithms sort information, rank posts and videos, decide what you see online, match people with products, detect faces, fraud, spam, help cars drive themselves. Algorithms decide what deserves attention, and attention shapes behavior. That's why algorithms are so powerful. They quietly sculpt the world you experience. But here's the twist. AI doesn't replace algorithms. It supercharges them. Instead of fixed rules like if A arrow do B, AI learns flexible rules. If A, B, C, D, and 500 subtle patterns, here's the best action. Algorithms built the modern digital world. AI is now evolving it. 6. How all these systems connect. GPT models learn from text, understanding human ideas. Algorithms decide what matters, shaping what we see. Digital twins simulate reality, predicting futures. AI supercomputers train the models, powering the system. Together, they form a new technological ecosystem. AI doesn't live in one machine. It lives across your phone, cars, hospitals, governments, entertainment, science, personal assistants, the economy. It's becoming the invisible infrastructure of the modern world. Just like electricity in the 1900s, AI is shifting from a strange invention to something everything depends on. Why AI needs so much data? One thing people often misunderstand is why AI needs mountains of data just to perform simple tasks. To an AI, a photo isn't a cat. It's thousands of pixels and mathematical relationships. A sentence isn't meaning. It's patterns in word placement, grammar, and probability. AI needs huge datasets because it has no intuition, no built-in knowledge, no common sense. Every insight must be learned from examples. That's why self-driving cars train on millions of hours of footage. Medical AIs learn from millions of patient scans. Voice assistants analyze millions of spoken conversations. AI becomes powerful not because it understands the world, but because it has seen enough examples of it to approximate understanding. More data equals better predictions. Less data equals confusion, errors, hallucinations. In a way, the size of the dataset becomes the AI's experience. Just like a human improves with practice, an AI improves with exposure, at a scale no human could ever match. Why AI gets things wrong? For all its brilliance, AI still makes mistakes, sometimes obvious, sometimes bizarre. Here's why. AI doesn't know truth, it only knows patterns. So if a pattern appears frequently during training, the AI will treat it as highly probable, even if it's wrong. It can mix up facts, invent details, misinterpret rare situations, fail when conditions change suddenly. AI performs best in stable, predictable environments. But the real world is messy, emotional, spontaneous. That's why chatbots hallucinate facts. Self-driving cars struggle in unusual weather. Image AIs mislabel objects in strange angles. Recommendation systems can trap people in echo chambers. AI isn't flawed because it's broken. It's flawed because prediction is not the same as understanding. The next leap in artificial intelligence won't just be bigger models. It will be models that can verify, question, analyze, and say, I don't know when needed. Once artificial intelligence learns uncertainty, it will become far more reliable and far more aligned with real human thinking. Artificial intelligence may seem futuristic, mysterious, even unpredictable, but at its core, it's built on patterns, probabilities, and human data, refined into systems that can create, predict, and simulate reality. It's not human, it's not alive, but it is incredibly powerful, and it's reshaping your world more than any invention since the computer itself. Thank you for watching. If you'd like to keep exploring the hidden systems shaping our world, please subscribe. This is microScope. Clarity starts with a closer look.